Let f of x be equal to x squared plus 2 when x is less than 1, or 2x plus 1 when x is greater than or equal to 1. First thing we want to determine, giving reasons where the function is continuous at x is equal to 1. So to be able to determine that, the first thing that we need to find is f at of 1. Since we want to determine if it is continuous at x is equal to 1, so what will be f of 1? So we look at these two equations, which one is including 1. So you can see that for this one which is down is including 1. So I'm going to say 2, where there is x, I put 1 plus 1. That gives us a 3. When we find f of 1, the next thing we need to find is the limit as x approaches 1 from the negative for the function f of x. Now from the negative side, you look at the equation which is talking about values of x which are less than 1. So this one is talking about values of x less than 1. That is from the negative side. So that is going to be, where there is x, we are going to substitute 1 squared plus 2, which is a 3. And then we also determine the limit as x approaches 1 from the positive side of f of x. Now from the positive side, we look at where the function which is giving us values of x greater than 1. This is the function. So where there is x, I'm going to put a 1. So that will give us also 3. Now when the limit as x approaches 1 from the negative and from the positive, they are equal, then the limit as x approaches 1 for the function f of x is that same value, which is a 3. Now you compare, f of 1 should be equal to the limit as x approaches 1 for f of x. If that is true, then the function is continuous. So how many things are you finding? 3 things. First, you find f of 1. You also find the limit as x approaches 1 for the function. And for you to find the limit as x approaches 1 for the function, you need to find the left hand side, the right hand side. If they are not equal, then that limit doesn't exist. And then the next thing, you will see if the f of 1 and the limit, they are the same. If this is met, then the function is continuous at that particular point. And then the next one is asking us to sketch the graph. So if we can see for this one, the critical point that we're talking about, the value of x is 1. So I'm just going to put 1 here. So for the first equation, this one which is on top, where there is x, I'm going to put 1. We see the y value that we're going to find. So if I say 1 squared plus 2, that is going to give us y being equal to, x squared plus 2. So where there is x, now I'm putting 1. That is going to give us y being 3. So I'm going to have a coordinate which is 1, 3. Now I'm going to put an open circle here. Why an open circle? Because we are not including 1. And then this one is valid for values of x less than 1, meaning that the next value I'm going to use, I can get any value less than 1, like a 0. I put here 0 squared plus 2, that is going to give us a 2. So 2 somewhere here. So this is the coordinate. The next one I'm going to use is a negative 1. Negative 1 squared plus 2, that is going to give us a 3 again. So it's going to be here. I can also use a negative 2 squared plus 2, that will give us a 4. So this is how the function is moving, and for this one is a quadratic, so it gets to move like this. The turning point is here, and then it continues to go up like that. And then we also have the values of x which are greater than 1. So I'll start with 1 itself and put in this function. That is going to give us a 3. So I'll have again 1, 3, but 3 is being included and 1 is being included, so I'll shade it. Why? Because here we are including 1. And then I'm going to get any value of x which is greater than a 1, like a 2. I'll put it there. So 2 multiplied by 2 plus 1, that is going to give us a 5. So I'm going to have 2, 5. Now if you see, this one is a straight line. So for a straight line, you just need 2 coordinates to be able to draw. So just draw a straight line like that. Okay, so this is the graph of f of x. And then the next one, find the equation of the tangent to the graph of f of x at negative 1, 3. Negative 1, 3, where is that going to be? Well, this is at this point. So what we want is the equation of the tangent. Let's get to draw the tangent. So the tangent is going to pass something like that. Should be able to touch that point, negative 1 comma 3. Okay, something like that. Now, how can we find this the equation of this tangent? The first thing is we need to determine the gradient, okay, of the tangent. And for us to be able to find the gradient of the tangent, we need to find the gradient of the curve. How do you do that? We need to find the derivative. So you can see it is cutting this curve which is here, meaning that the equation that we're going to use is this one which is on top, because that's the one which gave us this curve which we're able to see. All right, so we are going to say y is equal to x squared plus 2, and from there we find the derivative, so dy over dx, that is going to give us 2x. Now where there is x, we are going to put x value which is negative 1. So this is going to give us 2 multiplied by negative 1, which is equal to negative 2. But we also know that when you are talking about the gradient of the tangent, it is equal to the gradient of the curve. So this is actually equal to the gradient of the curve, and then you can find the equation y minus y1 is equal to mx minus x1. So this will be y1 is the value that we've been given there, which is a 3. That will be equal to the gradient, which is negative 2. X minus x1 is the negative 1. So this gives us y minus 3 being equal to negative 2 x plus 1. So I'm going to keep this 3 as I'm going to take it the other side. So negative 2 times x, that will be negative 2x. Negative 2 times 1, negative 2. And then I'll now get this 3, take it the other side, becomes positive 3. So that means the equation of the tangent is negative 2x plus a 1.